This is the Maths Unit 2 Calculator Allowed Intermediate paper from November 2018. Question 1 says, calculate 8.2 squared plus square root of 13. Give your answer correct to two significant figures. Now, it's a calculator allowed question, so literally you chuck that into your calculator just as it looks. So 8.2 plus square root 13. And it gives me a much longer answer than they've actually asked for. But if you write that down, you're definitely going to pick up one of these two marks here. So 70.84555,128 definitely goes down. That's got me one mark. And then to round to two significant figures, I put the line down after the second non-zero number. So 1, 2, even though that's 0, doesn't matter because I've already started counting. That's my second one there. So the line effectively coming down here. That number is the most important number there. If that is 5 or bigger, this goes up by 1. It is 5 or bigger, so it's 71. Not 71.0, just 71 to two significant figures. Next question, find 57% of 83.5, give your answer to one decimal place. So to find as a percentage, you do 57 out of 100, of changes to times. So times by 83.5, press equals, and again I get a number that's bigger than what they say, but to get the 1 mark, I want to see you writing that out. In fact, good idea to write in what you put into the calculator, 57 out of 100 times by 83.5. And then to get that to one decimal place, lines there, 9 is 5 or bigger, so that's going to be 47.6 to one decimal place. Okay, questions underneath. It says circle either true or false. All circles are similar. Now to be similar, all your angles have to be the same. So in terms of circles, all circles being similar, they're all 360 degrees, and if they're enlarged to each other, they're always in relationship, so that's true. All squares are similar, all the angles in a square are at right angles, and they're all the same size, so yeah, that's true. All triangles are similar. Now I can think of triangles that don't look the same. Now because there's less of a relationship that you have to have for just the generic word of a triangle, there's a right angle triangle, and then here's an isosceles triangle. Okay, so they're not similar at all. So that'd be false. Similarly, with rectangles, all the angles have to be the same, and also there's got to be a relationship between them. So for instance, I could have a really long, skinny rectangle, but I could have a really wide, fat rectangle. So that's not true either. And then it says all regular hexagons are similar. Well, that's very similar to being a circle and being a square. That regular means that all the sides are the same, just like in a square. If all the sides are the same, all the angles are the same, so that's also true. Okay, over the page. This question seems a little bit too easy to me. I'm worried that I've got the wrong end of the stick here. It says, one day, Gwyn was asleep for 8 hours and awake for the remaining hours. Draw an accurate pie chart to illustrate this information. Space for working is underneath. So we'll just move the camera there to the space for working. The space for working then, the hours that he was asleep, I'm going to say that it was 8 out of the total hours in a day, so 24, so I'm assuming we get a mark for realising it's 24 hours in a day, times by 360 degrees. So 8 over 24 times by 360 equals 120 degrees. Now, ordinarily, I'd actually be going and finding a couple of angles. So, for instance, if I was going to say awake, I'd go and work out what's left, which would be 16 out of 24, times it by 360 degrees, and then find that out. But it's not really that hard. It's just what's left in a circle, so that would be 240 degrees. Okay, then, so to draw this accurately, I need to have a protractor and a ruler. I always draw my line going straight up from the centre to the circumference. And then 0 must be on that line. Now 0 is on my line there perfectly now. And also you see my dot there. That's bang in the centre. It's not like skew-if like that. It's got to be bang on the centre and 0 on the line. And I'm looking for 120 coming around here, there. Find that that's come out. Not a problem at all. As long as it's accurate. That's 120 degrees. That's what's left, that's 240, which I don't need to measure because it must be what's left. That was my sleep. Really important to actually label your pie chart, and that was when I was awake. Okay then. Next question, number 4 says, choose any number, show that 1/5 of 25% of your number is equal to 1/4 of 20% of your number. Okay, so let's choose a number. Now, my advice to you would be to make your number super, super, super easy. Now, when you're talking about percentages, I'm choosing 100. So 100 is my number. 25% of your number, 1/5 of. So 25% of 100 is equal to 25. To then find 1/5 of that, I want to do 1/5 times by 25, and that gives me an answer of 5. Okay, so that's my right-hand side, or my left-hand side done. Left-hand side, LHS, left-hand side here. My right-hand side, RHS. So 1/4 of 20%, so 20% of 100 would just be 20. And then 1/4 of 20, so we times it by 20. 1/4 of 20 is also 5. Again, you can pop that into your calculator to check. 5 equals 5. So true. We've just got and proved it's true. Okay, probably the most challenging question we faced so far is asking me to tell my show my understanding to angles in a triangle, and look at that because of these dashes here. That means these two sides are the same, so the two angles underneath are the same. So I'm going to go and draw those in straight away. I know that angles in a triangle add up to 180 degrees, and from there I can start to work out this question. Let's just double check what it's asking me. It says ABC is an isosceles triangle. I can tell that from the picture. ABP is a straight line. Okay, so just for confirmation, it's not drawn to scale, but this is a straight line. So that also means that I know something about these two angles here. They must add up to 180, this one here and this one here, because they're on a straight line. Calculate the size of the angle C. So we're at C, then we go to B, then we go to P. So I need to go and work out what this angle on the other side of the triangle is. Okay, so first of all, what I want to do is find out any angles I can find, which is an easier one is to find the ones inside the triangle. So I'm going to say 180 degrees, take away 76. I put that into my calculator, and I get 104. Okay, so 104 degrees. Now, because I'm being assessed on the quality of my organisation and communication and accuracy in my writing, I've got to explain what my steps were, why I did it. So this is remaining angles in a triangle, or in the triangle, I suppose. Okay, so then I'm going to do 104 degrees divided by 2, which would be 52 degrees. So I'm actually going to go and write those in. 52 there, 52 there. I'm going to say angles are the same. Angles are, oh, hang on, you're not seeing any of the stuff that I'm writing here, sorry. Angles are the same because of isosceles triangle having two identical angles. Okay. Now I'm going to do 180 degrees, take away 52 degrees. So that's going to give me 128 degrees. Now in context, that this angle here is 128 degrees, and this is just, I'm just going to say here, angles on a straight line add to 180 degrees. Okay, now finally I just need to make sure that my answer is given really clearly. It says calculate the angle of size of angle C to B to P, which is this one here that I've worked out. So I'm just going to write CBP equals 128 degrees finally. Okay. Question 6. So question 6 says solve m over 2 equals 4.8. Now to solve that, I just need to get the m by itself. So to get rid of a divide by 2, I times both sides by 2. So m is equal to 4.8 times 2, which gives me 9.6. Factorise means put into brackets. It's the opposite of expanding, so I'm looking for something that looks like this. Okay, now because it's a minus sign there, it has to be a minus sign there. So I'm looking for a number that goes into both 6 and 15. Okay, so a number that goes into both 6 and 15 would be 3. Now this always has to be the highest common factor. In this case, that's the only common factor apart from 1, which we'd ignore anyway. And we say 3 times by what makes 6x? That would be 2x. 3 times by what makes 15? Well, that would be 5. Inside here, it shouldn't look like I'm able to factorise that again. Okay? Now the question below says factorise and y squared plus 4y. Now there is no number in both here, but there is a letter in both. So we're still putting it back into brackets like this. I'll put a minus sign there, but it should really be a plus because it's a plus in the question. So the thing that's in both is y. So y goes on the outside. Y times what makes y squared? Well, that would be y. Y times y makes y squared. And then y times what makes 4y? That would just be plus 4. Okay, part C says what is the value of the 6th term of this thing here? Now to work out any sequence in that nth term, change the n for open brackets and sub in the number of the term you want to find. So find the 6th term goes in here. So we're doing 3 times 6, which is 18, take away 20, gives me minus 2. Okay? If I want to find the 10th term, I just sub in 10. If I want to find the millionth term, sub in a million. Okay? Now, the question underneath says, consider the following statement. There are no odd numbers greater than 50 in the sequence. Show that this statement is incorrect. Now, what I'm going to do in order to find out if that's true or not is I'm just going to sub in a really big number. So the number that popped into my head was 100. 3 times by 100 take away 20. So let's see what that is. 3 times by 100 take away 20. Could have used 1,000 there. That equals 280. Now that's actually no use to us. That's proof that the statement is true. So what I'm going to do now is try a number really close to it, but hopefully it's going to give me an odd number. Now I just subbed in 100, which is an even number. So let's try subbing in an odd number, which is close to 100. So let's try 99, but we could have tried 101. So 3 times by 99, so notice, just delete the 100 and change it to 99. I get 277. This is odd. And over 50. Therefore, that statement's incorrect. Okay, I've just gone and found something that works. Okay, irrelevant that my first one did work. They've asked me to go and show that it didn't work. Well, I found something that confirmed what they've said. This actually goes against what they said. Okay. Okay, so looking at this question here, it says the 2 first spinners are divided equally into quarters and shown below. One spinner has values 10, 20, 30, 40. The other spinner has values 1, 2, 3, and 4. The 2 spinners are spun and the values are added together. That's the key bit here. It's my highlighter from before. They're added together to form a number. For example, 30 and 1 would make 31. So let's consider all the possible numbers that can be formed and calculate the probability that the spinners will form a number that is a multiple of 7. Now, to be a multiple of 7, that's obviously important here as well. That means it's in the 7 times table. Okay? So think of your 7 times table. It's just numbers that are in that. So 7, 14, 21, 28, and so on. Okay? So we need to think of a really clever way to display this information. And the way that's best to do this is something called a two-way table. So what I'm going to do is write out my numbers here that I could get, which was 1, 2, 3, and 4. And then the other numbers that I could get, which would be 10, 20, 30, 40. Okay? Now from here, the numbers get added together. So here I got 10 and 1, so that would be 11. Here I got 1 and 20, 21, 31, 41. Here I got 10 and 2, so that's 12, 22, 32, 42. Here, 13, 14. Here, 23, 24. Here, 33, 34. And here, 43 and 44. Now I'm looking for multiples of 7, so numbers that are in the 7 times table. So we already know 14 is, I've seen 14, there it is, once. Any other numbers? 21 is also in the 7 times table. 28 wouldn't be there. 35 wouldn't be there. And then after that would be 42. So there are 3 numbers that make it so. I would say probability equals 3, which is the number of options that work out of the total, which would be 4, 8, 12, and 16. So 3 out of 16. Next question says, give an approximate difference between 1 mile and 1.5 kilometres. Now you're expected to know this conversion. If you don't know it, you need to learn it. 1 mile is equal to 1.6 kilometres. So the difference between 1 mile and 1.5 kilometres, they have to be in the same unit of measure. Well, I know that this is equivalent to 1.6 kilometres. So the difference between them would be 1.6 kilometres, take away 1.5 kilometres. That would give me 0.1 kilometres, but it wants the answer given in metres. So to convert between kilometres to metres, you would times by 1,000. So 0.1 times by 1,000 would be 100 metres. Okay. Now this one here is really, really sneaky. Anything that talks about sort of like converting between areas is not as simple as it looks. Now my advice to you would be to say, draw a shape that you think you could find the area of to be 4 metres squared. Now, if I'm to give you an example of what I mean here, it'll probably be a little bit more easier. What would give me an answer of 4 metres squared in that shape there? Okay, well there's 2 answers. Either, if it was a square, it'd be 2 metres by 2 metres. 2 metres times 2 metres makes 4 metres squared, or it could have been like a long, skinny 4 by 1 rectangle. Now, metres changed into centimetres, that would be the equivalent to 200 centimetres. And the same is true here. So, if I'm to work out the area in centimetres squared, I need to do the 200 centimetres times 200 centimetres. So 200 times 200, 2 times 2 will give me 4, and 1, 2, 3, 4, 4 zeros will come in after it. So that would be in centimetres squared. So that would actually be the same as that number there. So it's not as obvious as just changing it or times it by 100. Area is a funny thing. So my answer would be 40,000 centimetres squared. Question 9. It says work out the area of the shape below. Now to do that I can see 2 shapes, area A and area B. I don't know what that shape would be. I don't know a formula to work out that shape. It's a pentagon because it has 5 sides. Now this is very easy to begin with because it says ABCD is a square, so that means that this must be 6.4 as well, because its base is 6.4. Now what that's doing here is if I know that's 6.4 as well, is I can go and work out what this difference here is. That tells me the height of my triangle, okay? That will give me this height here. So what I want to do is do 10.7, take away 6.4, which is 4.3 centimetres. So then my area of my triangle would be base times height divided by 2, or a half base times height, however you do that. I do it as b times h over 2. So that gives me the base, which is 6.4 also, times by the height, which is 4.3, all divided by 2. Okay, so I'm going to go and put that into my calculator. So 6.4 times 4.3, all divided by 2, gives me 13.76 centimetres squared. Don't actually need to put that into the final answer. B is even easier. It's just a square, so it's literally 6.4 times 6.4, 6.4 squared. That gives me an answer of 40.96 centimetres squared. So then my total area would be 40.96, add the 13.76, which gives me an answer of 54.72 centimetres squared. Okay, the next question Okay, the next question says the number is decreased by 12% of its value. Now, this is working with something called multipliers, and it's really, really, really efficient to work out what multipliers are. Now, it's very important to work out a multiplier. I'm going to give you this rule here. Multiplier. You do 100% add or minus percentage. Now, you would add it if it was an increase. If it was a decrease, you would take it away. Now, I can see here it says it's decreased by 12%. So you would do 100%, take away 12%. That gives me 88%, and then percent means out of 100. So it's 88 out of 100. Now 88 out of 100 would be 0.88. Because this is what we call a multiplier, and we're doing it 3 times, we would do 0.88 times 0.88, and then times by 0.88 again. In other words, we would be doing times by 0.88 cubes. Okay? Again, for percentages, you just need to know the following formula. It is the difference over the original times by 100. You have to learn that. If you don't learn it, you won't get any of these 3 marks here. Okay? Now, we're told that the percentage change, calculate the percentage change when 42.5 is increased to 45.9. So the difference would be 45.9, take 42.5, divided by what it was originally. Well, originally it was 42.5, and then times that by 100, and that just goes into our calculator. Okay? So 45.9, or press fraction by the first, 45.9, take away 42.5, divided by the original, 42.5, to the side, times by 100. Gives me 8%. Okay, question 11 says display the following information in a Venn diagram. The universal set, integers, now that just means whole numbers, between 74 and 80 inclusive. That means it includes 74 and 80. So my top tip to you would be to go and work out what this universal set is. That would be including 74, just the whole numbers until you get to 80 and stop. Okay, stop. We're then told set A is the even numbers. Okay, so every even number we want to select. So these are my set A's, which I'll just circle. So I'm just going to say I've circled set A's to my own mind when I look back. And then set B is multiples of 3, so things that are in the 3 times table. Now, I'm just going on a little bit of a whim of one that I know off the top of my head. I know that's a multiple of 3. Now, the reason why I know is because 25 times 3 is 75. However, if you're unsure, what you should do is add together the integers that make that number. So for instance, 7 add 5 would be 12. If that number is in the 3 times table, then this number is in the 3 times table. So 7 plus 5 is 12. Yes, that's in the 3 times table, so 75 is. Take, for instance, 74, and I do 7 add 4 is 11. 11 is not in the 3 times table, so 74 isn't, okay? So I know this is in the 3 times table. And then the next multiple of 3 would have to be 3 numbers further on, so it's going to be 78 as well. And again, if I do 7 add 8, I get 15. 15 is in the 3 times table, so 78 is. The next one will be 3 on again, but that's not included in my set. Okay? My Venn diagram is going to look like 2 circles that intersect. There's 1. There's 2. I'm going to call this set A. I'm going to call this set B, because that's what they gave me. And I have then a rectangle around it, okay? So numbers that are in both, so they're circled and highlighted, is just 78, so that goes in the middle. The numbers that are just circled is all the other even numbers. 74, 76, and 80 go in there. B is the multiples of 3 that aren't circled, so just 75 there. So numbers that didn't get highlighted or circled, so 77 and 79 come in here. Okay? The next question, question 12, says the table below shows values for y equals x squared plus 4x minus 1 for these values here. Go and find the missing values for minus 2 and 2. Now the easiest tip I could give you is to just change your brackets, change your letters to open brackets, and inside goes in the value of the number that you're guessing, okay? So I'm guessing, well not guessing, I'm going to go and find out minus 2. Minus 2 goes in there, into my calculator goes minus 2 squared plus 4 brackets minus 2, and then minus 1 from that. Press equals, I get minus 5, that's my answer. Then I'm doing it when it's just normal 2, so y equals 2 squared plus 4 lots of 2 minus 1. Rather than deleting all of that and starting all over again, if I just use the replay buttons, I can just delete the minus signs. I get 11. So that answer there would be 11. The next part of the question, it wants me to actually go and plot that onto the graph. So again, using pencil and a ruler where needs be, but just be careful if you've got an x squared graph, they always look like that, like a smooth sort of U shape or a smooth N shape. So we're actually going to do this without a ruler, but there'll be bits that we do need to use a ruler for. So we're plotting just these points here that they're given to us in the table. So minus 5 and 4. So minus 5 and 4 will go there, across to minus 5 up to 4. The next one is minus 4 and minus 1. So minus 4 and minus 1 will go there. The next one is minus 3 and minus 4. So minus 3 and minus 4 will go there. The next one was minus 2 and minus 5. I actually found that one, so that's right at the bottom there. Is what we could call the lowest point. Then minus 1, minus 4. Then 0, minus 1. So actually on the axes is where that should go. 1 and 4 should go there. And then you'll notice actually that these are what we call symmetrical. It could be a case that that happens, but it may not necessarily happen. Don't overly worry too much if yours isn't in future questions, but for this one it should be. And then finally, the last point is really up high there. Now, as I've already said, if it's got an x squared bit to it, it's got to be a free-handed curve. So I always go to my lowest point, which we call the minimum point, which would be minus 2, minus 5, and I start to draw it up one side. If I go wrong, I can just use a rubber and rub that out. Don't stop on your last point, draw it right up until the maximum point, until you hit the graph paper, and then similarly here, notice that I'm going all the way to the top of that graph paper there. Don't just stop there, go all the way to the top. Okay, so that's my graph. And then finally, just remembering to look back, I have missed part C on my graph, which says y equals 2. Draw the line y equals 2. Okay, well here's y. Where is that? Where is that axis equal to 2? Here. That is a line that goes straight through the y-axis at 2. And it's weird because it's parallel to the x-axis. But it's a really important graph, and the graphs of x equals, you need to be able to know how to draw those, okay? So that is y equals 2. And then go and write down the intersection. So here's where it intersects. So come down and read off that value there. Now I can move the camera. You can just move your little head closer to the question. You've got 0.6 there would be one answer. And then here, coming down and reading off here. Now I've got minus 4 there. That's minus 4.5, and it's one little square over, so it's minus 4.6 for me. Now yours may be different. If it is, don't worry, as long as you've read correctly from your graph there, you will get those marks at part C, as long as you actually go and write them in. So minus 4.6 was one answer, and 0.6 was the other answer. Okay, question 13. It says, Jonathan writes a whole number on a card. The number is between 55 and 83 inclusive. So, including 55 and 83, it could be any of these numbers here. The square root of the number is greater than 8, but less than 9. Now, that's giving me an inverse operation here. Not really interested about the square root of it. I want to know what it was squared, so I know what the original number was. It's sort of a little bit like me telling you oh, my age squared is this number, so well, just tell me what your age is. Square root that to find that out, okay? So in order to do that, you want to square 8. So let's do 8 squared, which is 64. 9 squared, which is 81. Now it says it's greater than, the square root of it is greater than 8, so it's got to be bigger than 64, but less than the square root of 9, so it's got to be less than 81. So it's somewhere between 65 and 80. Okay, that's what the first two lines have told me. It then says the highest common factor of 7 and the number is 7. Okay, now that's telling me that it's in the 7 times table. A factor is 7, regardless of it being 49. I know from 49, if I start doing the 7 times table, that I'm going to find out this number. It's just got to be somewhere between 65 and 80. So 49, 56, 63, 70, 77, 84. I'm going to stop there. I know it's not bigger than 80, so I'm stopping there, okay? It's not 84, it's not 49, it's not 56, it's not 63 either because they're lower than 65, okay? So it's either 70 or 77. Then it says 3/5 of the number is a multiple of 6. So I'm going to work out 3/5 of 70. I'm also going to work out what 3/5 of 77 is. So again, use my calculator for that. That comes to 42. Now that is a multiple of 6. Because it's in the 6 times table, it's actually 7 times 6. And then if I change that to 77, well that's got a decimal, so it's definitely not in the 6 times table. 46.2, not multiple of 6. So the number on his card must be this number here. It must be 70. It's the only one that works from all the clues that we've been given. Okay, the trial and improvement question, which always takes an age to write, but you have got 4 minutes to do it. Is you start off by drawing a table with a really, really wide middle column and 2 narrow columns here. Now, different teachers have different names to theirs. I'll just do what I do with my classes. I have a guess for what x is. I put in the formula here, x cubed minus 13x equals 107. That's what I've got to get. And here, I reflect on it, I have a comment, okay? Now, if they tell me it lies between 5 and 6, go and sub in 5 and 6. You will get a mark for chucking those numbers in correctly. If it says to 1 decimal place, it's lying to you always go 1 more once, okay? I.e., we're going to go to 2 decimal places, but only once, okay? So, first of all, best way to do trial improvement is you put open brackets in wherever you see an x. So, here goes open brackets, 5, because I'm putting in 5 as my substitution into both of them. So 5, close brackets, cubed, minus 13, open brackets, 5. Same number has to go in both because it said x and x there. Now that gives me 60. I'm supposed to get 107, so that's too low, it's not enough. So I'm going to try a bigger number. I'm going to try 6. And lo and behold, that's too high. Now that's great because it's just gone and shown that our number must be in between 5 and 6. I know they told us that, but you do get a mark for showing in the numbers that they've set. Okay? Now, I need to check somewhere in between them. If in doubt, the best place to go is 5.5 or something 0.5. Okay? Now the reason why is because that's bang in the middle. Now, this needn't be a hard task anymore. I've done all the hard work in my calculator. All I have to do is keep my calculator without pressing on or AC, using the replay button to delete the 6 and just move to each side and change it to 5.5. It's nowhere near as hard now. And that gives me 94.875. I'm supposed to get 107, so that's too low. So I'm going to try a bigger number. Now be careful, don't skip any values. Go in consecutive numbers. If you don't and you miss one, you will lose the rest of the marks. So in here goes 5.6 cubed minus 13 lots of 5.6. On your calculator, use the replay button, go through, delete the 5 at the back, and change it to a 6. It's as simple as that. 102.816, that's still too low. I'm supposed to get 107. So now I'm going to try, you guessed it, 5.7. Into my calculator, just delete the 6 and the 7. Now, it's really important that I log all of my guesses and I don't just do this without writing it down because I'm getting awarded for the marks. Now, I've just gone and got my second mark. So where they've come in was me going too low, too high initially, and then going too low, too high again. But what the examiner will do is check these are consecutive numbers, that it's the 6, then the 7, or a 7, then an 8, or a 2 and a 3. They've got to be next to each other. If I'd gone 5.5 too low, then 5.7 too high, I wouldn't have got the mark because I've got to narrow it down in between 1 DPs. Okay? So basically, what I'm where I am now, I've tried 5.6 and I've said that's too low. Try a bigger number. And what I have done is I've tried a bigger number, which is 5.7, and that was too high. So that's telling me to try a smaller number. Well, I've already tried the smaller number than it, that was too low. If I go any lower than that, it's just going to be too low and so on. Okay? So what I've got to do is decide, is this answer closer or is this answer closer? So what I do is I chop this exactly in half and go at 5.65, the number in between 5.6 and 5.7. So here goes 5.65 cubed minus 13 lots of 5.65. Okay? That gives me an answer of 106.912 blah blah blah. Now I'm supposed to get 107. So that's too low. It's really close to it, but it's too low. As soon as I do that, because I've shown my understanding that I actually go one more decimal place to check, I've got my third mark. Now finally, my final mark will come from choosing the right one. This was too low. Then I need to try a higher number. So I need to come somewhere in between here. I.e., that one is closer. It's closer to my answer here. Top tip if you're ever stuck, too low, too low, too high. What's the odd one out? Too high. You finally choose that as your number. X equals 5.7 to 1 decimal place. Okay, the next question is coming up from just your understanding of graphs, which is always written in the form y equals mx plus c. That is what we call our gradient, and this is what we call our y-intercept. It's just checking your understanding of being able to change the subject formula as well. Now this isn't y equals, it's 6y, so I'm going to divide this by 6 to find the gradient. So if I divide 3 by 6, 3 divided by 6 is a half. My answer is a half. What is the value of the y point where the line 5x plus y plus 3 equals 0 at the y-axis? Well, it's not in the form y equals. So I've got to get rid of that 5x and get rid of that 3. So I'm going to end up getting minus 5x minus 3. So the gradient of this graph is minus 5, but the y-intercept is minus 3. That's my answer. And then this one here underneath is a little bit sneaky. It's actually simultaneous equations. It says, what are the coordinates at the point where the equations x plus y equals 7 and x minus y equals 3 intersect? And if I write them above each other, it's a little bit easier to see. If I add those two equations together, x plus x is 2x. Y minus y is gone. 7 plus 3 is 10. If 2x is equal to 10, x must be equal to 5. If I know from here that x plus y is equal to 7, then I can say 5 plus y is equal to 7. So y is equal to 2. Now I'm not really explaining how to do that, I'm just going through it really quickly. If you're unsure how to do that, go and ask your teacher, okay? I'm not going to go through absolutely everything and how to complete it. The perimeter of a square is 76.4. Calculate the length of its diagonal. So let's just sketch out a square very quickly. Okay, so the distance around this whole square is 76.4. Now what I want to do is work out the diagonal from here. Now I notice I've got a right angle triangle here. And if it was a square, if I knew what this side was and I knew what this side was, I could use Pythagoras. Now I can go and work that out because I know the whole distance is 76.4. That's 4 sides of a square. So one side of square would be equal to 76.4 divided by 4. That gives me an answer of 19.1. And because they're all the same sides, that's why I can divide it by 4. So all of those would add up to give me the perimeter of that. Okay, so let's say P for perimeter. Now I know that, I can say that A squared plus B squared is equal to H squared. 19.1 squared plus 19.1 squared equals H squared. You might say C squared from your school. H is for hypotenuse, so I'm writing it as H myself. Now I'm putting that into my calculator. H squared is going to stay the same here. I'm just going to work out what 19.1 squared plus 19.1 squared is. SD it, that's 729.62. I'm now going to square root both sides to find out what H is. So square root of 729.62. Shouldn't have 2 decimal points there, that's a typo. It's 27.0114 blah blah blah. So my height, or not my height, sorry, my hypotenuse would be 27.0 centimetres to 1 decimal place, which I'm just writing down there. Okay? Penultimate question, we're talking about probability trees. Have a quick read through that question. Okay, right, I'm going to go really quickly through this question. I'm not really teaching it, I'm just going through the exam paper, okay? I'm not teaching these topics. If you want to teach them, go and have a look at some other videos. These are just going through the papers. Branches on a probability tree must add up to 1, so that must be 0.92, because 0.08 and 0.92 add up to 1. Similarly, these must add up to 1, 0.15 and 0.45 makes 0.6, so this must be 0.4. These options are independent, so independent there means that they don't get affected about the Saturday or the Sunday. So all of these probabilities remain exactly the same here. 3 marks for that, okay? It's really, really important you know your stuff for probability trees, so chuck marks away at it. It then says, a meeting is chosen at random. Calculate the probability that's held on a Saturday, so I'm interested in this branch here, and then it says that we travel by plane or by car. So there's 2 options that I can go here. So if there's ever more than 1 options, what we do is we work them both out and then we add them together, okay? So to work out the probability of going on a Saturday, it would be the probability of the Saturday multiplying in between my branches times 0.15, which gives me 0.02. 0.012. Here I do 0.08 times by 0.4, and that will give me 0.032, I believe, but let's just double check. .032. So then to work out what is the probability, we have 2 options, so if we ever have 2 or more options, we add them together. So 0.012 add 0.032. That comes to a total of 0.044. Okay, final question is on what looks to be either trigonometry or Pythagoras. The fact it's the last question, it's probably trigonometry because that's your B grade, it's your last page. And I can see an angle other than 90 given 4, so I'm definitely looking at SOHCAHTOA here, okay? So, when it says to work out the size of angle X, I'm looking at this triangle here. This is my angle, so this is opposite my angle. This is adjacent to the angle, so this is my edge of this top triangle. What I'm going to do now is write out SOHCAHTOA in order to work out the angle of this, okay? Now because I know the adjacent and I know the opposite, I'm going to cross off A and O's in SOHCAHTOA. I choose the one that is double cross off, so I'm choosing TOA. That is tan angle, that's what the T stands for, tan angle, equals the opposite side, so 6.4, divided by the adjacent side, which is 8.2. Now to get the angle by itself, what I want to do is get rid of the tan, so the inverse operation of having tan of something is to say tan minus 1. So x is equal to tan minus 1 as 6.4 divided by 8.2. So into my calculator, press shift and tan if we know both sides, so 6.4 over 8.2 equals, I'll write that here so it's nice and neat, 38.0 I make it, degrees to 1 decimal place. Okay. Now, using the camera here, I'm going to zoom right in. Okay. Right. You see here this symbol. This symbol means it's 90 degrees. We know this bit here is 38. Well, we know the whole thing's got to make 90. So because I know that's 38, if I do 90, take away 38, I get the answer 52 degrees. Okay, so I know this angle here is 52 degrees. Okay, it's coming back up now. Working just on this triangle. This triangle here, this is opposite the angle that I've just been working with. This is the hypotenuse. And then this little bit here, not the 8.2 because that's the full length, just to here would be the adjacent, okay? Now, I'm asked to go and work out the length of AQ. That's what it says down here. AQ is here to here, that's the hypotenuse. I know the opposite, okay? So again, writing out SOHCAHTOA and crossing off the sides that I know or want to know, so op and hype, so O and H. I could stop now if I want to because I've already crossed off 2. But if I go and cross off any more, you'll see that I only cross off 2 in SOP. That stands for sine angle, so sine 38. So they'll bring up a bracket, sine 38 is equal to the opposite side, which is 7.9, divided by the hypotenuse. Okay? Now, I want to get that hypotenuse not divided by, just by itself. So I'm going to start by timesing both sides by the hypotenuse. So I get sine 38 times by hypotenuse is equal to 7.9. Now finally I want to get height by itself. So I'm going to get rid of what's with it, which is a times by sine 38. So I'm going to divide both sides by sine 38. So what I want to put into my calculator to find out the hypotenuse is 7.9 divided by sine 38. And that gives me the answer of 12.8 to 1 decimal place. Oh, hang on. I made a mistake here. Let me just rectify that quickly. The angle of this triangle was 52. I went and worked it out straight away. So it shouldn't be 38. It should be 52 there, and 52 here. Oh, okay. So 7.9 divided by sine 52 comes to 10.0, right? So the hypotenuse is 10.0 to 1 decimal place. Okay?